Greetings, welcome to Self-Assessment 5, problem number 2. They ask us to determine if each of the data set is linear or exponential, and then once we've made that determination, we want to write the formula for each. So first off, we know that it's going to be one or the other. Either these are going to be either linear or exponential. They're not going to mess with us and have neither as one of the choices, okay? All right, so let's take a look at the first one. My suspicion looking at the p of x's is that this is linear, all right? But a first thing to notice, and I want to take a mark of right away, is the fact that that is 0 by 52 right there, which tells us that we know our y-intercept, okay? We know where we're crossing the y-axis. That's going to be an important piece of information for either exponential or linear. Okay, so next thing we want to do is decide whether or not it really is linear. So we have successive terms. We're in luck. We're moving in steps of 1. In other words, our delta x here from here to here is 1 and here to here, and all three of these, which that makes our lives a little bit easier. So we're going to go ahead and just be able to try for the slope by checking the successive terms. In other words, we know that our slope formula, m is equal to y2 minus y1 over x2 minus x1. In the case of the problem we have at hand here, in all of these, the denominator is always going to be equal to 1. Notice, because we're going by an increment of 1 is what we're increasing, and every time here makes our life so much kinder. Okay, so then all we have to do is take a look at subsequent y values. So if this is y1 and this is y2, then we've got 41 minus 52. Now, if that wasn't the case, if these were not sequential, then you're going to have to go through and actually, calculate the slopes by determining what that difference in the denominator is every time. So 41 minus 52 gets us back a negative 11. Okay, so that's the first one. So let's try the next set of problems. Okay, we'll take a look from y2 to y3. So y3 minus y2 divided by 1, because we know that's what x2 minus x1 is going to be. That's going to be equal to 30 minus 41 divided by 1. And by Jove, that comes out to negative 11 again. So looking really good that these are going to be linear. In other words, the common differences are staying consistent. In other words, we have the same value of the slope between any two ordered pairs that we select from our table here. So let's just, for the sake of completeness, let's go ahead and take a look at y4 here. And so we take a look at y4 minus y3 divided by 1, because we know that that's what x1 minus x2 is going to be for the entire thing. And we end up with 19 minus 30. And lo and behold, that is negative 11 also. Cool beans. So now we know two things. We know the order pairs 0b, and we also know what m is equal to. So with those two pieces of information, we can write the equation. We know that this is going to be linear. Linear infers to us y equals mx plus b. And so that tells us our final p of x here is going to be negative 11x. And then our b value right here was 52, so that's going to be plus 52. Cool. All right, let's go on to the next one. Okay, so looking at this, I already can see that these are varying by a power of 2. So 2 times 16 is 32, 2 times 32 is 64, and 2 times 64 is 128. So I'm not even going to bother to check if it's linear because I can already see that this is exponential. So to find out whether or not it is exponential, I mean, to put the nail in the coffin, so to speak, we need to go in and look at subsequent ratios. In other words, we need to see, is the ratio remain common between subsequent terms? So let's take a look at, first of all, we're going to look at y sub 2 divided by y sub 1. Y sub 2 divided by y sub 1 is going to be equal to 64 divided by 128. Hopefully that makes sense to you. I'm just looking at them sequentially here. And when we do that, we get back 1/2. Same thing here. If I look at y sub 3 divided by y sub 1, then we're going to get 32 divided by 64, and again we get back 1/2. And last but not least, if not y sub 1, sorry here, that was a y sub 2, apologize for that. And last but not least, if we look at y sub 4 divided by y sub 3, we end up with 16 divided by 32, which again is equal to 1/2. Okay, so that's cool because now we see that we know that our base in our exponential function, our base b, is going to be equal to 1/2. Now keep the b straight here. The b over here was for the y-intercept. The b here is for the exponential base. All right. So remember, with an exponential function, we're talking about y is equal to a times b raised to the x power. So a couple of things to keep in mind. Our value of a is going to be given again as the y-intercept, and so that's the value here of 0 by a, right? That's our initial condition, is how we say that in an exponential function. So g of x is equal to 128 times 1/2 raised to the x power. Hopefully that all makes sense to you. If not, don't be shy about posting questions to the discussion forum. So this right here, that is our exponential base. All right, let's get on to h of x, okay? So we take a look at h of x, and h of x, kind of wonder what I got going on here. Again, we notice we're kind of in luck that they give us the initial order pair. But I can already see, but looking at subsequent steps here, that the differences are not going to remain constant. 1100 minus 1000 is 100, and then, so, but it's not 1200, it's 1210 to get it to the next step. So it's not jumping up by a value of 100 every time, and we can see that from here to here we jump up by 100 again. So I don't suspect that that's going to be linear. My suspicion is, looking at the y values, is that we've got an exponential again. Okay, so let's see if we can figure out what that is. So let's take our subsequent values and form the ratios. So let's take 1100 and let's divide that by 1000. And when we do that, we get back 11/10 if you simplify that. All right, let's try that again, but this time we're going to take the next two y value, or the next subsequent y value up. In other words, we're going to take 1210 and we'll divide that by 1100. I'll let you do that on your calculator and say into frac, but you'll see that that's going to come out to be equal to 11/10 also. And then last but not least, if I take 1331 and I divide that by 1210 and do into frac, I'll see that that comes out to be equal to 11/10 also. So it looks to me like we have an exponential with a common ratio of 11/10, which means that the exponential base b is going to be equal to 11/10. We also see that our initial condition here is at 0, 1000. So we also know right away, hopefully without too much work, that that's going to be 0 by a, where a is going to be our initial condition. So h of x turns out to be equal to 1000 times the base of 11/10 raised to the x power. Okay, so quick aside, even though they didn't ask us to do this, let's just do it for the sake of completeness. We see that g of x, that is going to be a decay function. Why? Well, because we know that because the exponential base was less than 1 and greater than 0. And over here we see that h of x, this one is going to be a growth function. And the reason we know that that's a growth function is our exponential base is greater than 1. Not by much, but it is still bigger than 1. 11/10 is bigger than 1. Okay, well, hopefully all of that makes sense. Again, if you need any additional help with that, do not be shy about posting questions to the Q&A forum.